Lesson 3.2 on constructing perpendicular bisectors. Now, to start off today's lesson, we need to discuss what bisectors are. A segment bisector is a line, ray, or segment in a plane that passes through the midpoint of another segment in a plane. For example, let's say that we had ourselves these two segments, segment AB and segment CD. Now, a bisector could be, say, a line in the crossing across segment AB, or a ray, say for example crossing across CD, that cuts through the midpoint of either segment and divides that segment into two congruent parts. Now, a median is a special type of bisector that's found in a triangle. A median is a segment drawn from the vertex of a triangle that bisects the opposite side. For example, in this triangle here, we could draw a segment that goes from one vertex in the triangle and bisects the opposite side there. That is a median. You could also draw medians from either other vertex in the triangle to the opposite side as well. In other words, every triangle could potentially draw three medians with it. Now, a midsegment is another special segment bisector that's actually a segment bisecting any two sides in the triangle. For example, if we draw a segment from one midpoint of one side of a triangle to the other midpoint of another side of the triangle, that is called a midsegment, where it bisects two sides in the triangle. Now, there is another special bisector called the perpendicular bisector. A perpendicular bisector is a line that is both perpendicular to and bisects another line. So here we have ourselves a segment, segment EF. Now, the perpendicular bisector of EF would be a line that not only bisects segment EF, but also is perpendicular to EF. Now, here's where the construction comes in. Construction number 3 involves constructing a perpendicular bisector. So given the premise that you have a segment, say segment AB, and you're asked to construct the perpendicular bisector to AB, here's how that procedure works. You begin by actually taking your compass and pivoting it on point A. Extend your compass about 2/3 of the way to AB. It could be more than 2/3, it might be 3/4. You could even have it go all the way to AB if you wanted. Just as long as it's greater than half the distance, the compass needs to extend beyond the midpoint. Otherwise, this construction won't work. So after you extend your compass past the midpoint, maybe about 2/3 or 3/4 of the way, draw yourself a wide arc that extends far above and below the segment. Then, keeping the same gap in your compass, make sure you don't change it. Keeping the same gap in your compass, do the same procedure, but this time as you pivot your compass on point B and draw the wide arc above and below the segment. Now, you'll notice that these arcs meet in two locations, above and below. Now, taking your straight edge, draw a segment through these points of intersection with the two arcs. And there you have constructed your perpendicular bisector. Now, the perpendicular bisector also has a special property associated with it, called the perpendicular bisector conjecture. The perpendicular bisector conjecture says that if a point is on the perpendicular bisector of a segment, then it's equidistant from the endpoints. So pick any point on the perpendicular bisector. Any point on that bisector is going to be the same distance from both points A and B of the original segment. Now, in addition, there's also the converse of the perpendicular bisector conjecture, where, remember, a converse is where we swap the if and then statements in a conjecture. So now the converse states that if a point is equidistant from the endpoints of a segment, so the premise changes slightly, where now we begin with a point and a segment, and we say that that point is equidistant from both endpoints of the segment, then that point must be on the perpendicular bisector of the segment. Thus concludes today's lesson.